Welcome to our class. Today we want to again look at more other concepts in Noir. This time we're looking at generating a solidity verifier from Noir using Barretenberg. And we've done that before. But this time again we want to go up to Remix, try to deploy our contract there. So that is again one of our targets in today's lesson. So we will generate this solidity verifier and proceed to Remix to try and deploy. You can even deploy it to Ethereum platform or anything else, depending on what you want. But for us, we'll be doing that just on Remix. Now, again, as we've always done, it will be a hands-on lesson where we'll be doing things practically. So as I've stated, this guide is just to assist us with the steps of how to generate a Solidity verifier contract or verifier smart contract from Noir circuit using Barretenberg and then prove packet. So throughout this lesson, we'll learn how to compile our Noir program, how to generate Solidity contract, then how to deploy it using a Remix IDE. And the link for that is here. If you can use that link, of course, that's what we'll be using when we reach there. And then we will also verify our zero knowledge proofs on Ethereum virtual machine compatible blockchain. Now, who is this lesson meant for? Or who is this class meant for? Or whom can this class assist? It can assist first-time developers that are interested in zero knowledge snacks, privacy, and blockchain. It can also be of benefit, and of course, it's of benefit to anyone who is comfortable with the basics of Solidity and the Remix IDE. It will also be of use to students working with a working installation on Noir and Barretenberg. So of course, that means it's useful to all of us. So all of us are supposed to know it, because in one way or another, it will assist us. Now, so what are our objectives? I'd already said, one, we will want to compile a Noir circuit and create a Solidity verifier contract. Two, deploy and interact with this contract on a test blockchain. And then three, understand how the proof verification process works end to end. So those are the things that we are to achieve at the end of this lesson. Now, just a recap on Noir and Barretenberg. What are they? And Noir is a language for writing sanctity, privacy-preserving cryptographic programs or circuits. It lets you describe computations that can be proven in zero knowledge. And we've been doing this, and so we continue doing it. What about Barretenberg? What is it? This is a proving backend, or is a tool that takes your compiled Noir program and produces cryptographic proofs and verifier contracts, including Solidity contracts for Ethereum virtual machine blockchains. So it's just a tool that we'll be using to prove our Noir program. And at the same time, it will be giving us those proofs, those cryptographic proofs, and of course, assisting us in verifying the proofs. Now, why is this powerful? Why is this setup powerful? The Noir and the Barretenberg, what is it? Why is it? We are saying that it's powerful because one, it lets you to write private logic in Noir. Two, it assists us or it allows us to prove that we know something without revealing it. That is, we are proving it in zero knowledge. We know something without letting it reveal to the verifier. And also it lets us to deploy verification to any Ethereum virtual machine chain, such as Ethereum, Polygon, Optimism, etc. So it will allow us to deploy verification to any of this. And we'll be seeing, of course, how this can be done. Now, so what do we require before proceeding? What are we supposed to have? So before starting with this lesson, you need to ensure that you have Noir and you have Barretenberg installed in your local machine. Then you also require a simple Noir program, which we will write and use it to generate a proof, generate a contract, and it's this contract that we proceed with to the remix. So we just require a simple Noir program. If you don't have one, use you can even use Hello Noir example and proceed until you have the contract. But of course, we know how to write this. We've been doing it, and therefore it's easier for us to get one. We also require remix ID access, and we will do that using this link. When you use this link, it directs you to remix, and that is where we'll be doing our work from. The other requirement will be familiarity with the Solidity and remix. For us, we'll just be copy pasting, compiling, and deploying contracts because we already have, you see, once you already have a circuit and you've already generated the verifier.sol, the only thing you require now is just to copy paste it to the remix. And that is what we will be doing. Now, so once you have your circuit, supposing you created your circuit, you only need now to compile it. Compile your Noir program. And I've said that every Noir project is compiled into a JSON artifact, which is needed for proof generation and for building a Solidity verifier. And I'll be showing you that again. That it's very important. So when you do Nago compile, whatever comes out of that Nago compile is very important for us in proof generation. And again, after proof generation, we will require it in creating the verifier.sol. That is the solidity verifier. So that is why a Nago compile will be very important to us. So that is the first step we'll be doing after we've written our circuit. And you need to know why it's important here. We're not just doing Nago compile for the sake of it. We are doing it because the outcome of it is what we require. That is just an artifact. Is what we require. We'll be using it in proof generation. Okay, so the steps I will be using, and we will now go straight to doing it hands-on. So the first step we'll be doing is writing our Noir program. And after that, of course, we are writing that in the main.nar. After that, we will proceed to compile with the Nago, do Nago compile. And the Nago compile will giving us some JSON file that we will then be using in proof generation and generation of the solidity verifier. Now, so very fast, I'll want to open our WSL very fast so that we create a project. So let me now stop sharing what I'm sharing so that I share the WSL that we move together. Now, so my WSL is here, and usually my programs are stored under Rust programs. And so I want to create a project, make a directory. Let's call it hands-on class. Just an example. Just showing you how to create a project. Now, so we have hands-on class. Let's get inside. Good, CD it, and we are inside that class. So I want to create a folder called circuits. So CD circuits, not CD, we've not created it, So to create it is make directory circuits. Make directory circuits, good. Now we can get inside. Circuits. And we want to have, inside this, we want to have our SRC with main inside, and also want to have our nago.toml inside these circuits. So for us to achieve all that, we'll say nago initialize. Nago init. Okay, so as usual, my Nago is not the right path. So I have to have it the right path. I think I need to install my Nago properly so that it's the right path instead of every time getting this error. it's not well positioned in the path. It's not okay in my path. It's not in the path. That is why every time I try to have to do it manually, every time, that wastes a lot of my time actually. But for me to ensure that it's in that right path, I've just used this link, this command, echo export path home. So if you are with the same problem, that is what you do, and you press enter. And now your Nago is in the right path. You can now begin using it. So I want to do Nago initialize, and that's what I was to do that time. When you do it, you can see that you've successfully created the project. And this project is now is now stored inside home, Cyprian, Rust programs, hands-on, class, it's called hands-on class, and it's inside circuits. Good, now let's get it outside circuits. Let's get out of it. We are now in the main project. We want to open it. Code space dot. Okay, let me now share my VS Code, which is now open on my end. When I say the code space dot, that is what comes, the VS Code. And here it is. Good. Can see it's called hands-on class. That's what we just created. Inside, we have already circuits. Inside circuits, we have what we wanted. We wanted nago.toml and src. Our src has main.nr. This is already a code inside it. If you want, you can maintain it. But for us, we don't want to maintain it. Okay, it's already zero knowledge proof also. We want to maintain it, but we want to use the same code we used last time. In our previous class, we had a code that we used, and that's a code we want to use. The code that was testing, we have knowledge of an X, such that, what was it? It is the knowledge of an X such that array multiplied by X square plus B multiplied by that X plus C will give you a D. Give you a D where X is a private inputs, A, B, C, D are public inputs. Now, if you want, you can add tests to this code, but for me, it's not important at this point. But the tests normally we add them just to confirm that your main function is working as expected. And since we already had tested this in our previous class, it means that this function performs as expected, and therefore we have no reason to prove that it does. It does function as expected. We already did that in our previous class. Now, very important is that our circuit has only these three. Our circuit has only these three. And so if we wanted to produce that .json we talked of, which we'll be using in proof generation and verification, of course, and in the formation of the solidity verifier. Then we would want to get inside circuits, and just do nago compile. And when you do nago compile, you will notice that there is now target. Is now target, and that JSON we talked about is here. That JSON we talked about is here. It's called circuits.json. It's called circuits because when it comes to our Noir Nagotomil, the name of our program here is circuits. If you want, you can change it to hands-on. Call it hands-on class. Good, so we'll change it. So after changing it, you can even now delete this target and then we run nago compile. And now again, you check and you can see it has come with the name of the program as we expected it to be. So this is what we then use later in proof generation and also in solidity verifier generation. So we run that. Good. For us to do proof generation, we require another folder. It depends on how you want to do your proof generation. If you want to do it using yarn generate proof. If you want to do that, you want the folder here called JS. But if you want this, then maybe you may want just to use nago execute to get a witness and proceed with the BB commands. That is Barretenberg commands from Barretenberg. Now, so we will also require contracts, a folder called contracts, and that is where we will be storing our verifier.sol. So we require that. Require this too, this folder. Now, so inside this, we require inside this .js, inside JS, we'll require some folders, some files. It's just the same files you've been having, like for instance, we require generate proof generate proof.ts. I'm having this and interaction with these things, so it's not something new we've been having. So we just clicking on this JS and create a file and call it generate proof.js. This will be assisting us in the generation of the proof. The system in the generation of the proof. Now, so once you do that, you can paste in this code. You can see that it has some errors here. And the errors are coming from the name So for instance, we call ours hands-on class. So you can just come here and change this to hands-on class. Good. You can see the errors have reduced. There's not any other serious error. The others you can ignore. So the only one we wanted to change was this. Now, so we were assuming that if A is B, if A is 3 and B is 4 and C is 5 and X is 2, using that equation, our D will be 25. Our D will be 25. Okay. Now, so generate proof.js is not the only file we require. As we've always done, there are several other files we require inside JS, even including package.json and even tsconfig.json. tsconfig.json. So just come again, click on the JS, right click on it and new file, and the name of the file, that is tsconfig.json, and then you input the right code. Put the right code inside. For instance, for us, it will be this. So that's what we do. You will come to, again, on this, hands-on. You may want to come there and create another folder here. Just by just pointing here, create another folder, call it contract. Or if you don't want, you click here and then right click and again make new folder. You can see we have that option here too. Call it contract. Oh, we already had it. We already have it. So you only need to input and the files required for that. The files required inside that. That is the only thing we are supposed to do. Now, so inside the contract, we have several files. One of them will be tests. The test will require tests. So you just come inside this contract. And this is our contract. Right click on it and say new file and say test. Okay, what did I do? Again, right click, file, then call it test. Call it test. No. Test is not a file, it's supposed to be a folder. Test is supposed to be a folder you can delete permanently. Create a folder here called tests. Now, inside this folder called tests, you can create a file now called starter.t.sol. And once that is created, you put the required content for that. And here it is. Now, so there is one folder. Okay, we had that folder called the tests inside contracts. We can also create another, not folder this time, but a file inside contracts. And create another file, and I want to call it simply and verifier app.sol, and create that inside contract. I do not want it to be inside a text. It's not inside a text, because when you close test, you can see it. It's not inside a text. So it's not be inside a text. This is just inside a contract, but not inside a text. It's a file inside a contract. Okay, so let's give it its content. We've done this before. Now, inside this contract, there are many things there are many files I want to input. I want a file called base home verifier. Base home verifier, and I'll be explaining why that comes in, why we require it, because this is the only file that we've not been seeing in our classes. We've not been seeing, but again, it's inside contract. So create file called base home verified sol. Then after that, we'll give it the right the right content, the right code. So its code is here. Is the code for, you can see the imports. Hong.sol, hong verification key.sol, abstract contract, base home verifier, and so on. So we have that. Okay, so there's that hong.sol you saw there as an import. We also want to have it as a file inside our contracts. We also need it to be a file. You see, we've imported it, so it means we should also have it. So inside this contract again, another file, call it home.sol. After that, give it its rightful code, and the code for this is this. Again, you get to know why it's important in the course of this class. So we've added base home verifier, we've added home.sol. So what remains is just the home verification key.sol. The home verification key.sol. And that is what we want to create inside our contract folder. Again, it's here. Home verification key.sol. So after creating it again, we provide it with the rightful code, and we are importing again the home.sol. Now I've said that this holds the verification key for your compile circuits, and in production, this file is usually auto-generated by BP as a good point. And again, here we use a stub so that the verifier compiles and deploys library verification key, function, and so on. That's what is inside here. Good. Now, there's no problem. You can see our generate proof, but TS has is red. There's no problem. It will just be okay when we begin compiling. It will just be okay. Now, so I want to write a script that is build.sh that will automate compilation and generation of verification key, as well as a Solidity verifier contract generation. So the script, that's what I want to. So that should be inside our circuits. Inside the circuit file, call it build.sh, build.sh. Okay, so good. The only thing I need to change here is the name of our project. We call it hands-on class. So you just come here and change it. At this point, just call it hands-on. Is the only place I'm changing. The rest remain as they are. Okay, let me just see whether it works. I'm sure that I'm aware that we have not made the scripts executable. I need to make the script, this build.sh, executable, but let me see whether it can run before making it executable. Build.sh. You can see it's not executable. It says bash, permission denied. So that means you have to, first of all, make it executable. And I'd already shown you that process of making it executable. I don't know whether you still remember the command for making a script executable. Maybe you can try it before I use mine. The command I've given you earlier, if you can recall it. Okay. I'm sure you try to record that. And here it is. CHMOD plus X and so on. So that makes it executable. So you can now use build.sh and it will generate and perform its role. Build.sh. So now, okay, you can see that it has generated as target, and inside we have hands-on class.json that we had deleted, and it has given us verifier.sol. And so we have several .sols here. Some we did put manually, but this one has been generated, auto-generated. Okay, so we are done with that. So the next thing is to generate the proof. Get outside circuits, and then get inside JS. Just do that. I know that I've not included package.json. It's no problem. Let's try to see. We will want to install yarn first of all. And let's see whether it can run before installation. Yarn generate and generate proof. Yarn generate proof. It says no project found. So no project found. That means we do not have a package.json. Not package. What do you call it? Yes, yes. So it means we don't have package.json. If you have it somewhere, you can copy paste. But if you don't have, you can install it by running yarn init. Let's see what that does. What it does. Good, good, good. You can see that after that command, when you come inside JS, you have package.json here. Now it's there, so that means the project is there. So let's see what happens. I just want to take you step by step, so you understand all these steps. You can see we even have yarn, we have nodes, node modules, we have editor, config, you have JIT attributes, JIT, all these have come as a result of that one command. And even there's some readme here with only JS inside. Okay, let's now do yarn generate proof. Couldn't find a script name to generate proof. So inside your package.json, it's saying will not find a script called generate proof inside package.json. That is not there. That's what it's saying. So you see that one is just pointing us at package.json. Okay, so let's add it. Let's add it and see what happens. I cannot see the top of this. Okay, so let me see. I think I can copy package.json that I have somewhere. Then we just paste it. It already has that script. This is what it was asking for, the script generate proof. But it could not find it. We now have it. Script generate proof. So again, let's see if it will give us another thing to do. Just step by step. Again, tell it yarn generate proof. Yarn generate proof. Will it point us to installation of yarn? It says not found, not found, command not found, TS node. Command not found, TS node. What could that be? What could that mean? Command not found, TS node. What that means is that our TS node has not been installed. So that is why the command is not found. So that means you have to install TS node. And how do we do that? Just doing this step by step that you get to know. So you can say yarn add TS node TypeScript --dev. Give it time. Okay, so installing things here. Okay, that is done. Let's again see whether it has, will be asking us to do something else. Yarn generate proof. Oh yes, the proof has been generated successfully, and you can find it inside our target. There's a proof here, and then you have public inputs here, and so on. So the proof has been generated successfully. Good. Now, so you may want to verify this proof. Want to verify this proof? So to verify this proof, get out of JS and get inside circuits. Get inside circuits. And then there's a command we've always used. I've always given you that command that we use to just verify the proof. And it is called forge tests. And of course, this will require us maybe to install a few things, even Foundry. Did you get inside the circuit? It was supposed to be, we were supposed to be getting inside contract, not inside circuit. We're supposed to be getting inside contract. Now, so what I was saying is that this command is used to verify the proof is done inside contract, but we don't have Foundry. I think it will want us to install the Foundry. Yes. Should I reinstall, or should I copy what I have and just paste it? Okay. So I want us to install Foundry. But first of all, I want us to check whether it's installed or not, so that I can know how to proceed and check whether it is installed or not. And I can see it's there. You can see, okay, that is 4G version. Okay, but it talks about tests. Let me check if I have tests inside my contracts. Yeah, it's there. The starter.t.sol is there. Okay, but what it's talking about, as I already indicated, is it requires the foundry.toml. Let me just create foundry. Foundry 4G is installed, but the foundry.toml is missing in our project, and it's supposed to be inside our contract. It's supposed to be inside our contract. So when you come to contracts, right click and just say new file, foundry, .toml, and then let me just paste its content. Now it will accept. Now, so I've just created that foundry .toml and then pasted some content inside. That is one way. The other way is I could use forge inish I was avoiding that because it would come with so many things. It would come with so many things. Let me show you what I'm talking about. What I'm talking about is supposing I delete the front tree vectorial that I just created and come here at the contract in the terminal and say forge init. Okay, I think the problem is this dot here. Oh, it can't run on an empty. So let's just do what it's telling us. It's telling us is to use force. Let's just use it. Okay, so when you come here again, now you find it has been created. The boundary which we had deleted has been created. Is only the only thing. Is not the only thing that has come in. Several other things have come in as a result of this. Several other things have come in as a result of this. Now, let us not forget our target. Our target was just to verify the proof that we've generated. So let's go back and see whether it's now okay. Although we went into very many things, we only required the verifier.sol and then proceed to only require that and proceed to remix. That's all we wanted. But I thought, okay, let's just generate the proof and so on. You can see this one has an error, and it will be easy for us to find where the error is. Okay. So, okay. Let's just come here. First of all, I think the error is still coming as a result of this. Is it? But generate proof, it had generated for us the proof appropriately. I don't know why the error is coming in. Let me delete that. Just delete that. Well, that's the course. And we will do it. I think the problem would be as a result of installation. Would be a few things we might install. Just check and just check the warnings, error. Check the error so that I can see where the problem is. Oh, so it means that we've not allowed foundry paths. We need to set the environment variable foundry allow paths to explicitly allow us to allow Forge to read files. That is where the problem is. That Forge is not able to read the files. So that is what it's saying. So there's no problem. Let's allow that. Okay, so I think just run export foundry allow paths circuit target so that foundry is able to read our target. We can, after that, let's again run the same command we were running and it has been failing. I want to see whether failed to extract foundry config. But now you can see it's like it has reduced the error which was longer, now is shorter. The good thing with finding these errors is that they help us to learn. So instead of just allowing doing that, since it's not working, let's do it inside our foundry, allow it inside our foundry. .toml. Let's just allow it inside our foundry. .toml, where was that? Yeah. Okay, that will now work, I think. Let's allow it there. I want to copy this command again, this time, and use it and see whether that command will just input inside our foundry, whether it will work. And it has not. And it has not worked. Or maybe I did not write it properly. I did not write properly. Okay, so let me just again do a few changes on that foundry because I'm convinced that is where the problem is coming in. Okay. Let's again try. Let's see what happens. What? Expect you expect? So Foundry expects Foundry allow parts. What do we have? Okay, let's change this Foundry again. But I don't know why this will not work, and yet I've been using it elsewhere. So it means, why can't it work for this? Maybe just a few installations here and there. Maybe it may just be Foundry as such. It's not Foundry as such. Okay, but we already have what we wanted, the verified at solved. But we insist we want to prove first of all. No, verify the proof. Although we already generated the proof, we just want to verify. It's now okay, we verified the proof. That's how we verified. So the problem was just on the founder.tool. And we have now cured what the problem was and the path. Okay, let's now not waste a lot of time on this. Let's go back to our remix. So we go to our browser. Let's just go to our browser. And inside our browser, search for Remix. You can use the code, the link I had given you in the slides. It is https remix.ethereum.org. Okay, so let me just come there. Just come there. Create. I want to go to my browser also. me share my browser. Okay. That is the link. So we allow it time to just okay, it's there. We are there. Come to create new workspace. You can see here, create a new workspace. When you click on it, it gives you workspace templates. And let's come to, you can choose basic or the blank. Let me choose the blank. Okay, I have blank one. So for you, you have blank one. For me, it has given blank two because I have some blank ones already on this same platform. Now you can click on initialize workspace as a new Git repository. That is, if you would want to commit it to your GitHub. If you want to commit whatever you get to your GitHub, then you would click this and then okay. Now, so it gives you this place, Explorer. Below this Explorer, when you point on this, you can see create a new file, create a new folder, and so on. And again, even when you right click inside, you have new file, new folder, download, and so on. So we want to create our new files, the ones that are in our contract. In our contract, we had what? We had base, home, verifier.sol, all those that we created inside our contract, the ones we want to create files for. So just come here and click on new, and then click on that, and then copy the same content we had and paste it there. For the base home verifier, our code was this. Can you just close? That's no problem. Okay, the other one was Cyprian app. Cyprian verifier app.sol. Also create a file for that. So just come and click. And then copy code for that. And again, just close. The other one was hong.sol. Hong.sol. So create that also. Hong.sol. And give it the correct Okay. Yeah, that was the home verification key. Again, get its correct content or code. Then lastly, if the verified is solved, okay. Now, so we have this compile. Now you see, what is compiling here is the verified.sol. So if there is a way of compiling all of them together, you would have used that. But if there is none, you would be clicking on one and compiling at a time. So for instance, if I click on that, that is base home verified.sol. In fact, that's what I was supposed to have done. I should have done it beginning this. But the verified.sol is done last. So you can even begin with this home and then compile that one alone. It's compiling. You can see it's compiled. It is compilation is successful. You can now click on the next one. You can even click on this home verification key, then compile it. And again, that has compiled. You can even now come to this base home verifier and again compile. And again, it is successful. Then come even to this and then compile it. Why is it red? After compilation, it's not red because it has now compiled. It's now okay. Now, so then lastly, you can compile this. Lastly, you can compile the verified.sol. Again, there's some warning here. Let's go and see what the warning is. The warning says the contract code size is bigger. This verified.sol, the size is bigger. So although it compiles, but it gives that error. So when you come back here and you go to advanced settings, allow optimization, and reduce this to anything below 50, it will supposed to work because the size of our contract is bigger. So we have it now as 50. And also compile it now and see whether it compiles without warning. Okay, so the warning has disappeared. It's now compiled. The verified sol has just compiled. Let's go back to, I don't know whether this one is also has a warning. This is Cyprian verified sol, Cyprian verifier app. I don't know they had a warning. Let's just go back and click on it. Let's go back and click on it. After clicking on it, let's compile and see if there's a warning, because I can see its color is different. Then we'll get to know what the warning is all about. There is no warning now. It's now the color is now okay. There's no warning now. So I think the warning that was coming to it was just a result as a result of the warning that was coming because of the verified sol being larger than what is expected. And so when we changed that from 200 to 50, the warning disappeared. Good. Let's go to deploy and just press deploy. Okay, so we cannot deploy Cyprian verified sol. What we're supposed to deploy is the verified sol. So let's just go back and click on the verified sol. But you can also try this, although this one you're not supposed to deploy them. What we're supposed to deploy is the verified sol. So when you click on this, what you get? It says this contract may be abstract. What if you do this first of all? After compiling, now do that. So it says that. Okay, but what we're supposed to be deploying is not that. What we're supposed to be deploying is the verified sol. So you click on that, we'd already compiled. Now, if something is already compiled, it will indicate. Let's just again do it. Compile the home. And see, it says compiled without errors. Go to Cyprian, compile it. Does without errors, compile. Come to this. Compile without errors. Come to home verifiers verification key. And again without errors. Okay, but finally we want to look at the verified sol. And this is all we need to deploy. Now it says this contract may be abstract. What that means is that there are other functions that we have not defined. So that then becomes our work that we're supposed to do. What functions here have been defined? So let's look at that so that in our next class we are able to deploy. Look what, so you see, once you deploy, it's supposed to come among the deployed contracts. You can see here there's 0 deployed contracts. But once you deploy it, it's supposed to be among. I just want to show an example. I want to deploy something that is not supposed to be deployed. We'll see what happens. You can see I've deployed something that is not supposed to be deployed. When you come, you can see deployed contracts. You have one, and it's here. So we have saved transaction recorded, deployed contract, but now the contract deployed, you can see is a hong.sol, but our real contract that we're supposed to have deployed is not this. But when we try to deploy our real contract, it's giving us some, it's saying that subtract. That means we then come and we go and find out why it's saying that. So that next time when we meet, we have an answer to this. But I've showed you what it's supposed to do. Once you deploy, if it's correctly deployed, it will write here. I think we should stop at this and then please come back in the next lesson with a solution to this. Thank you.